When you analyze business data, you will often want to know whether two sets of values are related. One way to do that is to calculate correlation. Previously, I showed you how to calculate covariance, and as a reminder, here is that formula. The idea is that you multiply the differences from the mean for each value pair. So we have two columns of data, and we have an x and y value that are matched up, and you find the sum of that product. You then divide that total by the number of data pairs. Correlation is related, and here is the formula. So you'll see that the top term is the same, but it's divided by the term shown. And it takes a while to explain, so I will just ask you to accept the term as given and use it in your calculations. So the next question is, how do you interpret your correlation values? You will get a value between 1 and -1. Data that is completely uncorrelated returns a correlation value of 0. In other words, the two sets of values have nothing to do with each other. Data that is positively correlated will be between 0 and 1. And if you have 1, that means the data sets move in lockstep. In other words, they move the same way all the time, every time. And if you have data that is negatively correlated between -1 and 0, then the data moves in opposite directions. So when one set of values goes up, the other one goes down. And of course, it's possible to have values between 0 and 1 or 0 and -1, and that means the correlation isn't quite as strong. So let's take a look at a visual example of data that is not correlated. Here I have 5 starting values, and those are 1, 2, 3, 4, and 5. You can see those on the horizontal axis. And 1 produces 2 results, 3 and -3, and the same for the other values along the horizontal axis. What this means is that the starting value tells you nothing about the value that follows it. The x says nothing about the y, so the correlation is 0. If you have data with a perfect positive correlation, in other words, a correlation of 1, then you'll see that it goes up and the values exactly match. 1 gives you 1, 2 gives you 2, and so on. It doesn't have to be this exact pattern, but you can see a visual example of what a correlation of 1 looks like. And data with a perfect negative correlation goes in the opposite direction. The next question you have to ask, of course, is my correlation significant? And that depends on several factors. You have the number of measurements, whether a value can be positive or negative, and by that I mean if you're looking for a positive or negative value only, in other words, one side, then that's called a one-tailed test. If your difference can be either positive or negative, then you have a two-tailed test. And then you look up the correlation value in a table, which you can find in statistics textbooks or online, and see what that looks like. And here is an example of a two-tailed correlation lookup table. N, the leftmost column, gives you the number of samples that you have, and then to the right, you have different confidence levels. And you subtract that confidence level from 1 to give you the value that you want. So for example, in the column next to N, 0.1, you subtract that from 1 for the 90% confidence interval, or confidence level. And then to the right of that, you have 0.05, so that's 95%, 98%, and the other two values you see there. So if you have 10 values and you calculate the correlation and you want to look at the 90% level, then you would need to have a correlation value of at least 0.55, and that's the value at the intersection of 10 and 0.1 to have a 90% certainty or 90% confidence level that the correlation is valid. And the various other combinations are available here. So again, there are a lot of moving parts to correlation, but it is a very useful way to look at your data.